Welcome, Collective Nation. In the studio, we have Jared, tech virtuoso who co-founded OctoML, the powerhouse propelling the gears of machine learning systems and ops into the future. Our guest has helped craft the architecture of Apache TVM, tune the performance of cutting-edge compilers, and now he's building bridges between open source ingenuity and robust product offerings. Jared comes from the PhD halls of the University of Washington, next to big tech giants like Amazon and Microsoft, to now leading the charge in OctoML's hiring across diverse roles. We decode the DNA of machine learning systems, explore the symbiosis of open source software and commercial ventures, and unveil the vibrant energy of Seattle's tech talent. This is your portal to the minds crafting the future. We look not only at the what of AI, but the why and how it's transforming our world. Let's dive in. All right, Jared, thank you so much for joining the pod. We'd like to start off, if you could just tell us about your prior work experiences, why you chose those positions, what you're most proud of, and how that led you to your current work.
Yeah, thanks for having me. My background is kind of all over the place. I joke that I've never actually had to interview for a real job at any point in my life because I sort of have had one, chance encounter to another. So I sort of showed up in college completely undeclared, trying to figure out what I was going to do. I tried to go to music school and sort of failed. It's just a longer story for another time. And I spent like the first year I had programmed a little bit when I was like, 12 or something, but I was writing like AppleScript or, I wasn't like serious programming. So I showed up at college pretty much unable to program, not really sure what I wanted to do. I was always kind of interested in science. The first quarter I took like a CS class, but it was right when CS was starting to become impacted again. So you couldn't actually easily get into major and it was kind of stressful. And so one thing led to another, and I ended kind of starting to program that year, and I took a couple classes, and I ended up taking a class in this sort of special program at UCSB that I ended up joining. And one of the professors was like, "Hey, do you want to come work at this startup that I'm doing?" And it was like 3 people. So that was my first real job. And they were building like a file storage product, right? Like Dropbox was out, but it wasn't hugely popular yet. And I don't think Google Drive was out, and this was designed more for banks. So I kind of got dropped with almost no programming experience into building like an entire web app for a Dropbox-like experience and porting the client from there was also a native client from Mac and Linux to Windows. So I was like writing Windows C++ and trying to learn Ruby on Rails, which was still relatively new at that time in my first summer. And so it was actually extremely challenging.
Well, Ruby on Rails is a very easy language. It's so beautiful. So maybe that made things easier.
Yeah, but you're also like, I literally knew nothing. They're like, "Can you do the throughput on this?" I'm like, "What's throughput?" And so it was one of those like trial by fire experiences. But I worked there for about a year. That startup failed miserably in the grand scheme of things, like because it looking back, it had none of the right ingredients for being successful. Just like people were part-time. It was like no one was completely focused. It was in a crowded market. It wasn't really clear how we were going to sell the thing. But I feel like I grew a lot, which was really good, and it helped me pay for school a little bit. And so I had a good time. I think that led a little bit to me doing more of that. I ended up working in another startup in the area while I was going to school for the next couple of years. And they were sort of building phone intelligence, or I think that's what they call it these days. But the goal really was sort of double click for phone calls. So ad tracking, ad attribution, performance marketing. And so I ended up there, and they were about 20 people when I joined, and they grew to almost 200. So I got to see sort of the scale up experience. And I was like the intern to the CTO sort of, which would be good preparation maybe for my current life. And we just built a bunch of features, and I got the chance of a lot of responsibility, even though I was still really young. And so I think all those things set me up. While in parallel, though, I was doing research. And so I think that really led to a lot of what happened for me is that after a couple summers working there, I was like, I really want to go to grad school. I've been working in open source for a while. And then I was just like, I want to do these deep things. How do I do that? And that sort of the path revealed itself to me, and I decided to do that. And then, I think my PhD I worked a little bit while I was doing it, but it dovetailed directly kind of into doing OctoML, which is what I was doing when we started the company.
Awesome. Well, Jared, we always like to kick things off with icebreakers. As you know, we're huge fans of icebreakers at the Collective, and start every event from our large summits to our tiny little living room meetups off with an icebreaker. And one of our favorite questions to ask is, we really feel like this gets to know somebody. If you could teach a class on anything, any subjects in the world except for generative AI or technology, can't be that, what would it be and why?
I think that's a hard one because I feel like I like doing a lot of things. I probably would teach a cooking class. I think that would be it. I think that's like the partly I would choose it because it's accessible. Like you can teach it to a lot of people, and I think it's something that you can do in like 1 course, let's say, or a couple courses where people can actually have some meaningful progress. And I think a lot of people actually have never really been taught to cook at all. And there's like, I feel like cooking has this sort of, there's a lot of low hanging fruit. Like you can get some really good like return on investment from a few tips, like simple things like people don't season their food enough, or they don't wait long enough, or they don't follow instructions the first time they cook stuff. And things like that alone actually can improve the outcome of cooking quite a bit. And maybe this is like my performance engineering mindset applied to cooking food.
Totally.
That's a very good point. I feel like, I don't know about you, but I try to like think of my day in systems and like processes. And I think that has a lot to do with like, there's like system design books that you read, like, but so I definitely resonate with that. I think also recipes and like cooking it's like a repeatable process that needs to be optimized. I think that's there's some parallels there.
Yeah, but I think the thing that I like about cooking at least too is that it also requires some intuition. Like, I mean, honestly, most engineering tasks, it's not, also, so because I almost went to music school, music is another metaphor that I like a lot. But, there's like this jazz quote, I think it's a Coltrane quote or something like that, which is like, you learn theory to then like forget it all and improv, or,
right.
There's something to that effect, and I'm probably misquoting it. But I always think about that. It's like the practice and the structure is there to sort of build the fundamentals and that systems thinking. But then often when you're in the moment, you actually have to kind of think on your feet. I actually think on cooking, that's one of the things that people struggle with too, is that they're both not literal enough and too rigid. And so they're like, well, I cooked it for 2 minutes, but like if you're browning something, if it hasn't caramelized, like it isn't going to be good. And, kind of being able to like learn the rules and know when to apply them or break them. I think it has definitely a lot of, there's a lot of versions of life or things you can do in life where that applies. So I feel like living by that is always good.
Yeah, I think this is a common pattern. Like people would say that about Bob Dylan as well, where he took a number of years to master the history of music, and then later kind of broke the rules. Picasso was the same way. So it probably applies to engineering in all sorts of fields. But yeah, would love to now dive into your experience in AI and what types of lessons our listeners can take away from those experiences. So first of all, could you just tell us about a specific project or challenge you've encountered during your journey at OctoML, where insights from the research community had a significant impact on the development of machine learning systems or tools?
Yeah, so I think for obvious to me reasons at least, but not obvious probably to listeners, is that OctoML sort of started as an academic spin out. So I think for us, some of these insights that have had a significant impact for the development of them are the same reasons why we started the company. So a little bit more history. So my background for a long time was I worked as a web developer. I'm mostly like a systems programming languages person by training. I'd worked on Rust, the now popular programming language, back before it at 1.0. I had worked at Mozilla for a little bit on it. I'd worked on Microsoft Research actually on 2 experimental programming languages, one of which is now has like a, not a new life, but a lot of mathematicians are using it to do formalized math. It's really cool. Like Terry Tao, who's like a very famous Fields medalist that people know, has been like blogging about it recently. And it's really cool to see stuff you worked on have this like future life. But I've been working on this sort of world of like, how do users write programs? How do we optimize them? How do we reason about them? And that's a very different world than what people are doing in machine learning. But I was also going to grad school. I started at UW in 2015. And for people who are younger, who are going to school now, the idea that machine learning is like not a core topic in computer science is probably wild, because like there were no machine learning people really at UCSB. There's like one data mining person, which is, related, but it wasn't like no one cared about it in the same way that they did. And so when I started, deep learning had kind of, the seeds had been planted in like 2012, 13, whatever. And I started to watch in 2015, like people started to build some of the first like real applicable models and systems. We saw my friend Joe is the one who did YOLO, and he was sitting next to me in the lab, like working on that every day. And when he would buy a new GPU, he would like rewrite all of his C++ code or sorry, C code even. It's not C++ code. And I started to see some of that happening. And I was really curious about like, how do we make certain domains more productive? And then my co-founder Tianchi at the time was working on MXNet, and TensorFlow had started to come out. And so there were lots of thoughts swirling. And I was looking for a domain to apply after I'd come back from working at Microsoft for a little bit during my PhD. And I was kind of at one of those years of my life where everything was being renegotiated. And so I ran into Tianchi and I was like, hey, like, what are you working on? He's like, we're going to try to build this like compiler-like thing for deep learning. And then we started talking, and then I was like, man, there's actually a ton of problems here that no one's thought about, and then that was a kind of a key moment of applying some research insights to really push the state of the art. And I think where we ended up was, and kind of the foundation of our technology that we built the company out of was, 5 or 6 grad students and a few open source contributors were able to beat NVIDIA, CUDA and N performance on I think it was a 1080 at the time. And that was like, oh, wow, maybe we can really like push this further. And we really realized that systems was one of the key ingredients in the ML evolution. And so that was like where I think for us, understanding kind of all of our collective backgrounds and the research insights we've learned over time, and then seeing how that like applied in this kind of ML area, and then realizing kind of, to me, ML kind of breaks into 3 pieces. There's a systems aspect, there's a data aspect, and there's sort of the algorithms, or what people would call models. And people were building startups and doing a lot of work on the data and the model side. The systems was mostly just like people hacking it here and there. And it wasn't until around that time when people started to take it seriously. So there's kind of confluence of things happening. And I think that's where it's had a huge impact, obviously, on the company, on my journey, on my own life, in terms of the way things had unfolded and changed.
So, I mean, you mentioned the YOLO model, you mentioned MXNet. These are some groundbreaking sort of transformations in this field. I mean, do you have any tips for kind of surrounding yourself with people that are of that kind of caliber, or working on really cool, exciting things, that you sort of tips for other listeners who are researchers or engineers in the space?
Yeah, I think my personal way that I've lived my life is talk to a lot of people around you, and pay attention to what's going on, and find people that you want to be like, or people that are doing things that you find exciting, and figure out how they got there. I think sometimes people also like look forward with the wrong advice, where they're like, I want to be A, but then they're like, I'm going to go do B so then I can become A. And I think if you kind of ask your question of like, why can't I do A now? Like if you want to be doing research now, then like, why would you go? Like the one I've heard a lot is like, people are going to get some like kind of unrelated masters or something, and then try to like enter a field where it's like, that's not actually the path that anyone doing that took. Like when I was working at Mozilla, one of my versions was all the people, except for maybe 1 or 2, who were on the team leading the language, were all PhDs, like every single one of them was. And so there was a little bit of like, oh, well, how would I get a job like that? I think asking those questions and then putting yourself in good environments, to me, makes up most of it. And then finally, like I said, again, the paying attention part, because one thing I've seen that some successful people in writ large suffer from in terms of finding what they really want to be connected to is that they sort of don't change their desire or change the way that they're thinking about it. So it's like, oh, well, I really want to be involved in this world, and the way to do that is ABC at this time point. And then as time goes on, what you actually are connected to and what you desire might really, I'm triggering reactions on the video. What you might want to do really just kind of might evolve. And I think that that willingness to change your mind is another characteristic I've seen in these people who are really successful, is just being able to be like, for example, for me, I think if you asked me like when I graduated college, I would not have wanted to work in machine learning. I'd be like, no. I had these sort of like loftier ideals about what I wanted to do, but I think I updated my model for myself, over time, and I found that has not failed me yet, because if you're around smart people and you're paying attention, like opportunities will show up.
Whoa, what's more loftier than working on machine learning? I can't think of any.
I don't think it was lofty, right? At one point, like I think that's also like, if you go back to like the Jan LeCun or Benji or any of the Turing, Hinton, like the guys who all the Turing Award and the related people working in the area, like they were all working in an area that everyone thought was kind of stupid.
Exactly.
For, years. And I think that's also part of it, is if you just follow this idea of what is interesting, then you don't necessarily open yourself to the most, transformative opportunities for yourself, because often what is going to eventually be the cool thing that people want to be involved with isn't cool at that moment. And you can't really like bet on that well. At least I don't know. I don't have an oracle for that.
Yeah, definitely. I mean, I think you also saw this, prior 2000s, people were really focused on scaling up, centralized compute. So how do you make the computer faster? And then I think companies like Google and Yahoo kind of built their competitive differentiation on how to take, commodity hardware and scale it up and design algorithm systems around that. So if you had been, someone who's just totally kind of chasing that trend of, scaling up compute, as opposed to taking the same compute but creating systems around it, you would have missed that entire boat.
Right. So my concrete version of this was, some of the people I looked up to were the people at the AMP Lab, which was one of the incarnations of Berkeley Research Group, but when I was an undergrad, which was like Matei and Ben and all these people who ended up doing Mesos and Databricks. And if you ask like, how do I have a career like that? the wrong strategy wouldn't be to go work on exactly the same problems they're working on. And I think that's the thing that people get caught up in, is that they tangle the concrete with the abstract part of their objective. And I think that's partly of something that you want to figure out for yourself.
So, I mean, you've had a diverse range of experiences in computer science, from web development to machine learning. How has this multidisciplinary background shaped your approach to building machine learning systems, particularly within Apache TVM? I think it has definitely impacted, at least the way I view things. I think people who come from pure machine learning often purely focus on maybe statistics and probability, whereas I think people who come from more of a software engineering background as well, they think about how you design machine learning systems that scale, various other range of problems. But curious to hear your thoughts there.
Yeah, I think for me, because my background, I used to say in grad school, like, I'm politely broad, impolitely unfocused. But I think a huge part of it is actually just being able to get out of your own point of view, which I think also in the startup is extremely valuable, because often I think one fundamental mistake a lot of people make is that they believe that their customer or their user and them are the same person, or like the same persona. And often when you're the builder of the tool, like, you're not actually your user, like, you're different people. And so I think being a tool builder is really like getting out of that mindset for me. And I think being in different areas has helped me kind of understand how differently people think. Because if you take like the Ruby on Rails developers I used to work with, many of them were very effective at their job, but they're not deep computer scientists. Some of them didn't have a degree. They probably didn't. I actually worked with someone who didn't know that, like, the complexity difference of an array or a hash map, or why to use one, and it was fine. He was still really productive. And so if you're like come from a world though where like everyone is like a ML PhD, you also overfit to a perspective where people are going to want to do jobs or tasks to be done that they don't even think about. And so I think, especially in this world, one thing that I think we've observed is, in order to build a system that is effective, you really have to cross-cut across a lot of layers right now. And furthermore, in the last 6 months, year, the users of it are just normal developers. So it's like, how do you take this super complicated thing, package it up, go all the way from like the architecture, like the GPU microarchitecture understanding, all the way up to like a web service that makes this scalable and cost effective for someone in low latency, and then provide it to them in a way that they can use it to build their application. And being able to like span that is really challenging, because it's hard for one person to even be able to inhabit all those spaces. And it's even harder, or as equally hard to even find a team, because recruiting a team that's like that diverse is challenging. And so I think that's where it's really helped me personally. And I always think back to, there's like this Steve Jobs quote about, you can't connect the dots looking forward, you have to connect them backwards. But I feel like every year that feels more and more true to me, which is like, oh, that random thing I did for that 1 year is coming in use again right now, even though I thought it would be, I'd never use that again or something like that. So that's the way I think about it, at least.
Jared, I'm curious, your multidisciplinary approach to your career, your work, it's obviously helped you out a lot. What are some of the concrete ways that OctoML has benefited from taking this approach?
Yeah, I mean, I think it's even in our DNA from the founding team, right? Like, if you think about it, like, there's 5 of us, one for one. So there's not like a cult of personality or a single founder kind of world. And all of us are, my other co-founders are not too dissimilar either. So like Luis, who's CEO, Luis has had a really varied career. He's a computer architect by training. He worked on Blue Gene at an IBM back in the day. He worked on like low level, computer architecture, multiprocessing cache behavior for a while. He had this whole phase of approximate computing, which now seems maybe prescient, which was where you're okay with the results not being fully accurate, which mirrors a lot of what happens with quantization and machine learning these days. And then for the last 5 years before this, he'd been working on DNA data storage as his area. And so Luis is this huge lab that he booted. It's like 30 or 40 people at UW still working on this, and they made a New York Times. And so he's had this very wide career. Jason, my other co-founder, is a bioinformatics PhD by training, worked at a life science unicorn company, and then at a hardware company, and then at Intel, and then here. Thierry's a computer architect. Tianchi is like a machine learning person with a hard system slant, but definitely more machine learning. And I'm like a compiler, web developer person. So I think part of that is just like in the DNA of the company. But I think it gives us that unique perspective, which is that we really see that you have to kind of go top to bottom, because the efficiencies and the cost and the scale of all this stuff is so sensitive to everything right now, that not being able to actually break the abstraction boundaries is a huge limiting factor to even being able to build the right product or get the economics of it right.
Yeah, fascinating. We're both UW guys. I have a soft spot for Seattle, you know, having spent some of the foremost formative years of my life there. Talk a little bit about that, about being in Seattle. You know, I know we last ran into each other at Madrona's conference a few weeks back. That was a ton of fun. It's a fantastic city. What in the coming AI wave, in the coming AI revolution, what kind of role do you see Seattle playing when, you know, competing with the big guys, competing with the Bay, with you know, with other research powerhouses?
Yeah, I mean, this is my model, and I know people are like hotly contested about how they think about this, but I feel like obviously the Bay is still the center of gravity, like writ large in the US for like tech and tech innovation. And I think there's like kind of this like tier 2 cities like Seattle and New York, and you know, I don't know, some people might put like Boston or whatever, Austin, you know, the people have other places they put on this list. But I think to me, at least in the enterprise and the AI side, like Seattle is like, that's like clear number 2, where like no one else is really in that bucket, and even maybe competitive with the Bay in some ways. And I think part of that is just, you know, obviously you guys know, having been here, there's a huge presence of the cloud providers. You know, even Google has expanded its presence of Google Cloud here quite a bit. You know, Amazon's obviously been founded here. Microsoft, the same thing as well. So I think there's like a lot of that talent. And then I think partly because of UW and AI2 and you know, kind of just the ecosystem, including some of the history at UW as well. You know, for the listeners, before OctoML, we were maybe the third, you know, large AI company to come out, or larger in terms of just raising money and people and such, out of the CS department at UW. Before that, you know, there were 2 companies that were acquired by Apple, and they used that to really seed and build out a huge AI presence here in Seattle. And I think that, you know, Facebook traditionally has had a huge, or Meta now, sorry, has had a huge AI presence here. And so I think there's just a lot of like raw ingredients in Seattle for it to be a place where there's a lot of interesting things happening. I think the challenges are, historically, it has not been as entrepreneurial, I feel like, as the Bay. And you can see it even in the department. Like we had an entrepreneurship speaker series, something like 6 or 7 years ago when I was at UW. And the students were like, how do we de-risk doing a startup? Which it's like, you don't de-risk it, you like embrace the risk and take the leap. And I think that that's like probably a key part of what I think is still changing. I think one aspect that's also helped though too is that prior to COVID, the capital was very geographic. Like you'd have to move to where the investors were. Like famously, the Bay Area people didn't really do deals outside the Bay. The Seattle people didn't really do deals outside of Seattle. And so I think that's also helped because there's more money in Seattle now, where I know a lot of VCs I'm talking to are coming here for board meetings, and they're doing deals here. So I think just the raw ingredients are good. And I think it's going to be a place where we're going to see a lot more happen, and the ecosystem is really springing up. So.
Yeah, I mean, my read on Seattle, that's you know, a great point about the post-COVID thing. You know, my read has always been, there's so much talent that's locked up that, you know, that Seattle has to offer, from, you know, from UW, from, you know, all these companies up there, a lot of research, biotech, but it's all locked up in institutions. You know, my experience as a CS undergrad, all the smartest kids just get piped into Amazon or Microsoft. And I think having watched Seattle from afar post-COVID, I feel like there's, you know, post kind of big tech doing layoffs, you know, rates starting to, you know, be where they are now. I think there's more of a drive for, you know, these smartest kids coming out of these places to go do something more entrepreneurial. Have you felt that as, you know, a leader of a top startup in the Seattle ecosystem?
I think there's more interest for sure, but I still sense like hesitancy. I think part of it's also like a pipeline problem in some sense, where, you know, there's not the connective tissue of, like, for example, when I was in grad school, I don't think there are any other startups I know about that were founded by students that were like a success story. Like even I believe Exnor, the 2 people who are co-founders are Ali, who's a professor, and one of his postdocs. Carlos, like a couple of his students were involved, but it kind of actually came out of like CMU. You know, like some of the students were from CMU, and Carlos had just moved. So there's not like, you know, a sense of like your friends going to do a startup, you know, especially like, you know, if you go to the Stanford, you know, CS department, the PhD students, tons of people are going to do startups. People are quitting their PhDs, you know. Obviously it's storied, right? Like I used to joke that being a Stanford dropout is probably more valuable than having a degree from anywhere else, at least in like tech. And I think that there is that world there that just there's really big pipeline of like everyone understanding what it looks like and how they do it and how you could go get funding. And when I go back and talk to people in the department, like people just aren't thinking about it in the same way. And I'm sure if that's true at the graduate level, it's also true at the undergraduate level. And so I think just kind of building that awareness and also I think having some success stories, because then I think people get it in their minds. Like I know, for example, Berkeley historically was not nearly as entrepreneurial as Stanford. I think, you know, kind of the series of successes at, you know, Databricks, et cetera, has driven more entrepreneurial culture. Like one of the Madrona investors who Sudeep, who's now at Decibel, another firm, he was at Andreessen around when they had done the Databricks investment. And he was saying Berkeley had that energy too, where there's just not a lot of startup activity, again, in comparison to Stanford, but I think, which is like maybe the top bar or high bar for there. But I feel like that's a huge part of it. And I think just trying to encourage people that it's possible and that there's interesting stuff going on. Because I think that just when you don't understand what the path looks like, it's really hard to engage at all.
Yeah.
So I think, you know, one of the good things that San Francisco has is the know-how. So computer science curriculums, and then also the startup principles, but then also the culture to support creation of software. One of those things is the open source community. So, right, obviously these debates go back to the operating system days. What is your work, you know, includes the contributions to the open source community through Apache TVM, but how do you see the role of open source in advancing the field of machine learning? And what benefits does it bring to both researchers and practitioners? So that's one. I think very clear case on that side. But then on the other side, building a durable and long-term business, how you view open source's role in that side as well.
Yeah, I think with open source, like to me, it feels clear cut, which is like open source has been the engine that has advanced all of this in so many ways. Like even if you go back to the, you know, the deep learning genesis in academia, you know, early Torch, not PyTorch, early Torch and Theano and all of these libraries were written by academics. They were open source and they drove a ton of the early innovation. I think even then the big companies, you know, sort of donating, if you will, in some sense, TensorFlow and PyTorch and MXN and all these big pieces of code into the public to drive innovation are the reason why machine learning is happening the way that it is. Because if you think about even the OpenAIs or the kind of the juggernaut companies in the AI space, all of them are building on top of a huge amount of open source. I think the other thing that's driving that too is that because much of this is based on using hardware acceleration, you know, NVIDIA has built a huge amount of the value here that people are benefiting from. And I think without that driving, we would have also not been in this world. And they've given away the software part almost for free because they're, you know, the model of their business is drive selling chips. I think there's like a confluence there where, you know, the ability for me to take as a graduate student a roughly off the shelf commodity GPU and write some code and then scale it up to a cluster and do all that in sort of the same software ecosystem has really been a key part of it. So I think it's a huge, huge aspect of it. I think what's challenging now and we're seeing play out is what does that look like when the economics of producing one of these models is so crazy that, you know, you can't do it as an individual anymore. And I think, you know, people like Facebook, Meta, sorry, it's hard to deprogram myself. You know, Facebook, Meta are still doing things like this where the release of Llama 2 was something that I had predicted they might choose to do like at the beginning of this year. And I think when they did it, was it almost surprising it happened so quickly, but you can see that it's catalyzed so much to happen. And even the last, I don't know, it's been only 3 months, 5 months, whatever it is. And so I think that open source is gonna be a huge part to play still for this. I think the only challenge on the company side, as you asked, is that building an open source business is hard. And I think, you know, it doesn't make it any easier. Like even in the hype doesn't make it easier. Because I think really what it comes down to is you need to understand where you can build boundaries around what your product is and what the open source is. And I think sometimes people have run companies for a long time without understanding that. And I think that's still playing out today. Like you can see, I think even the tension of whether you hold the models back as private IP or whether they're open and like how people are monetizing it. I think you see different strategies from stability to, I mean, Meta, it's very clear because they're an ad company. Like they actually have only things to gain in my mind by opening models up, and it's actually value destructive to their competitors. But if you look at like Google and OpenAI, like they have a quandary in front of them about what they're going to do. So I personally don't think there's much value in keeping the models closed, but that's like a debate people can have.
Because I mean, I remember when fine-tuning models was a bigger kind of thing that all companies were doing, as opposed to just picking, you know, OpenAI API. People were saying that, hey, if you use a proprietary model, you can use proprietary data and build up a differentiation through that respect. And so definitely there's a lot of benefit to people grabbing some of these open source models and incorporating them into their stack. And it's interesting to see that change as people kind of ping an API, maybe use RAG instead of fine tuning their own models. But we'll see some limitations to that methodology as well. So we've kind of dived into your contributions on an individual level to open source. Maybe we can talk about a high level as a technical leader of an AI organization. What qualities or skills do you value most in potential team members as you work to advance machine learning? Some people will value statistics, others will value hacking together an application using Hugging Face. I think what I've seen, doing a lot of coffee chats in San Francisco recently in the past year or two, is that there's a lot more, as you actually alluded to as well, software engineers getting into ML space without kind of learning a lick of linear algebra or multivariable calculus. Whereas before, people I think at least felt that they needed to watch Andrew Ng's Stanford machine learning course or understand the deeper level details there. So curious to hear your thoughts on that.
Yeah, I mean, I think you kind of gave me the lead a little bit, but I think it's like in that I think you really do need a lot of set of skills, because I think this is actually the shift that I see, having been being in the market for 5 years makes me like ancient, I guess, in this world, or even longer than 5 years, but like 5 years running a company or 4.5. Like I think that there was a world where everyone was an MLE or a PhD researcher or something like that, and that was the world, and it was all about concentrating your advantage with your own models. And I think the foundational model perspective on the world has just changed things a lot, which is the economics are, it's kind of like an operating system thing, right? Where it's like, no one's going to rewrite Linux. Like they might write like a driver or something, but they're not going to rewrite it. And I think it's the same thing. If it's $100 million to produce my model, and I spend 90 on the foundation model, or someone spends 90, and then I spend 10 to fine tune it, or build the systems on top of it to make it effective. Like, I think that's the world we're ending up in. But as you do that, we kind of zoom way out, and it's not just about like the machine learning part anymore. Like one problem we've had actually that recently that we ended up debugging was we had like uneven like load distribution at some point, and it was causing us to not get like the scaling that we expected from the GPUs. And this is like a pure like web service queuing, traffic dispatch problem, or right. There's like simple things on like how do you encode the output data. I mean, like for example, using certain encodings for images and stuff is extremely expensive versus other ones. And like none of this is a machine learning problem. So I think that when you zoom out, and you're building this world, you really need, and you need the machine learning people as well, because then let's say you want to fine tune the model, then you do need that person I was talking about before. But I think understanding that you need that mixture of skill sets, and like AI is not the silver bullet where you're going to go out and hire like 10 PhDs and then like get rid of all your software engineers, which I think some people have been like telling this sort of, sensationalist AI doomer kind of story that like everyone's gonna be replaced and we don't need anything else. Cause like there's so much code that goes around the model. Like a metaphor that I've been using is that I think if you think about a hard drive for a second, in like 1990, I would buy like a server and put it under my desk, right? Then like maybe I built my own data centers, and then I would maybe rent Colo, and then like, I'd buy VMware or something. And then I bought EC2 and S3. And like S3 gives the abstraction of like an infinite hard disk that's like globally available to you, but it's this insanely complicated system that requires thousands of human beings to run, millions of hard drives, and it's just really complicated. And so I think the model to me is the hard drive right now, and I think we keep thinking that we're at S3 already, and there's going to be new primitives that show up in the future, and like all the code that sits on top of it might have nothing to do with the model, or it might have much less to do with the model. Like even in these RAG or retrieval-based systems people are talking about, a huge amount of like how do you like fetch data and like incrementally pre-compute indices and like for your vector databases, et cetera, which is all like kind of classic retrieval, like software engineering, big data problems. So I think we're gonna, as a hype cycle kind of dies down a little bit, I think people will realize that there are a lot of other skills needed. And building a team of only AI experts, it will actually probably leave you in a worse off spot.
And one more point to that, at least found point on this topic. I think you make a very good point. I think great engineers, particularly AI ML engineers, will design the model and the APIs around their model in such a way that people won't need to know what's going on underneath the hood. And that's actually a hallmark of a great engineer, to be able to do that, as opposed to someone that needs to tightly couple the model with the rest of the software engineering stack as well. Right.
I think just to add a little bit of that on like something we were doing on the product side is that like instead of offering, like you could say every single model is going to have its own API. And so like if you want to hit any customization, there's going to be a million APIs will bloom. But on the image side, we've been moving to a standard API that allows you to specify the kind of customizations you want, whether it's checkpoints or LoRa's or textual inversions. And so there's like one API, and we're actually running tons of models under the covers, right? And we're dealing with like, where do we distribute the weights? How do we spread traffic? All these other things, but you don't care about that. Like if you're, and maybe that's actually the thing I should have said, which I should have led with, which is I think the skill in anyone in a world like this is understanding what the outcome you're trying to achieve is and being very outcome focused. Not that process is important, but like, what are we trying to help people achieve? Because I think then you can not see the forest for the trees or vice versa and end up building the wrong things. And so like, does a user care what model they're using? No, they want a primitive that helps them generate an image, right? Or like maybe there's some higher level need that they even have. And so just, I think being able to ground back to that is super important. And to your point, like then you'll design the right thing and you won't end up with this sort of like weird midpoint. And I think we've observed many of those in the ML market where people are building things that are not right exactly what people want.
I knew something was going wrong when non-technical people like have asked questions like, oh, what model are you using underneath the hood? And it's like, when you're driving your car, do you ask what engine you're driving? Who is the manufacturer here? It's like, no, it's a BMW, it's a Ferrari, it's a Ford. It doesn't matter what's happening to you as a customer.
Right. Well, that's actually where the S3 metaphor came from for me, as I'm like, I was talking to a friend. He's like, well, no one asked me if we're running on a Toshiba hard drive.
Yeah.
And I was like, because like actually even in cloud computing, you mostly don't think about what chip you run on these days, right? Like you buy vCPUs and memory, and that's worked in the like cloud web app world because roughly if you turn the vCPUs and the memory up, your application scales like linearly roughly with those. The problem is GPUs break that whole world. And so you don't have that abstraction anymore. And I think my, spiritual quest is to get us back to a world where things feel more abstracted and I don't have to worry about the details. Cause like it was the same thing. People are like, are you running an A100 with like 24 gigabytes of A100 is at 40 gigabytes of VRAM versus 80. It's like, like the average like developer should not need to be thinking about these things. Right.
Yeah, definitely.
Yeah, Jared, I don't know if you're, I'm sure you're probably familiar with Stuart Regis, very controversial.
For
CS
many
professor.
reasons, yeah.
Very, very controversial. I won't get into the weeds there, but, what I'll say is when I took his class, the biggest takeaway, he just like instills the beauty of abstracted away systems and, in a software engineering context. And, I think we're very, very early on that journey with ML, applying those same principles there, especially as barriers to building AI have been coming down so much. So, love that you're looking at it through that lens. Listen, you've had a big year. There's a lot to celebrate here. So, first of all, congrats on the recent launch of OctoAI. Talk a little bit about that. I remember being there. You guys launched a suite of some pretty impressive products. What was the kind of the conditions that led up to this? And I think it's been around 4 months. How's it been so far?
Yeah, thanks so much for all the kind words. So I think a lot of it was when we first started, we saw, again, kind of back to some of these metaphors, I think we had built this optimization capability, which allowed us to move models to different hardware devices or change their latency or change their precision. And we're like, this is really awesome. There's a ton of value here. I think the challenge is like, how do we package that and deliver that to people in a way that helps them achieve the outcome they care about was something that we were struggling to figure out over the last couple of years. And, we were finding people were interested in the value and the optimization front. But I think we were more and more like, man, it's really hard because we don't really control everything that we need to. There are like all these kind of like little sharp edges. And another metaphor, I feel it's almost like having virtualization, which is this amazing piece of technology, but it's not really a product. Like if you think about it, like you're buying EC2, you're not buying like the ability for the Intel CPU to do virtualization. And like there's so many layers of abstraction in between you, including like the hypervisor, or now with Amazon, they have Nitro, which is like their whole system for doing really efficient virtualization and networking. They even built their own hardware to do that. And so your experience is this like virtualized computer running, but like you're not thinking about like the core mechanism in the CPU. And so I think we've kind of been in the same boat, which is like, hey, what can this enable? And then I think for us, another catalyzing moment was seeing the closed APIs kind of come on the scene where, oh, maybe you can actually provide an API that is good enough for people that they don't want like white box control of the whole thing. Because I think that was partly what's happening in the previous world is you had a small number of organizations, were incredibly sophisticated, who wanted full control over everything. And from a product building perspective, it's very challenging to build a good product in that space. I think you see that with a lot of the ML ops companies from that era. It's just really hard to build the right product for people because no one has the same workflow. The models aren't in the same format. They don't deploy them the same way. And so I think all that was like kind of swirling in, what year was that? 2022. There was like a lot of thinking. And so about a year ago, actually, I was like, me and a couple other leaders inside the company were like, hey, we want to do something new. And I think like about January, February, we had a sketch of what we were going to go do. And then so the whole year's really been just pushing towards getting that out the door. And I think for us, we really want, kind of to the metaphors I've been using, is building this sort of next generation infrastructure in the form of sort of the OctoAI, which we released, which allows us to sort of run, tune, and scale all these AI models that people care about.
Yeah, definitely. And you make a good point about this previous era of ML where things were kind of swirling around. People wanted a lot of control. Obviously Octo was founded squarely in that period and operated for, a good couple of years there. Talk a little bit about how the foundational work that you guys did informs some of the work that you're doing now with generative AI and helps those systems run.
Yeah, that's a good question. I think part of it for me is the proof is in the pudding a little bit. Like, I think in just a couple months of doing this, we've seen like 10,000 people sign up. We're doing like millions of inferences a day. And we have even customers are doing like 1 million by themselves. And I think that's like this big change where before it was like we were doing this much slower enterprise sales motion with all these companies. And so I think we learned a lot about the deep technical problems in that spot, and that informed a lot of what we're doing. But I think the challenge is like, that again, that we saw is just, oh man, like it's really hard to package this up. So I think that like that's been this super guttural, like, visceral, like body experience lesson of just really the packaging and stuff matters so much. And we learned, to kind of more tactically to your question, like I think we learned about how people are serving these, like what the hardware requirements look like, what people's true latency requirements look like, what it meant to take some of this stuff to kind of production quality, even how to like use our own tools that we had built effectively. And all that added up and helped us quite a bit. And I think helped shape our understanding of how to kind of both go to market and also just to think about, even how to expose the technology to people.
Totally. And looks like you had another Zoom or
I know. Apparently it's an operating system level thing that now is like triggered in Sonoma and you can't stop it, or like maybe there's a way to turn it off now, but I don't know.
That's hilarious. That's hilarious.
Right. So kind of going back to the conversation of being a CTO at Okta, as CTO, you sit at the intersection of product engineering, R&D, and can you share a recent example of how this interdisciplinary role has led to the innovation within OctoML's offering? Because I think the role of being CTO changes as you move from maybe more vertical application-focused software company versus a more machine learning infrastructure play, right? That CTO role becomes a little bit different.
Yeah, I mean, so one thing that and this is just one opinion, but my best understanding of what a CTO is has actually gotten more ill-defined, I think, over time. Because I think I've spent the last couple of years, like there was one moment where I joke and like I went on like a vision quest or whatever to talk to a bunch of people about it and like how they approach the job. And I found that there's just so many ways that people do the job. And I think to your point, so much it matters what the company looks like. And so, if I was CTO of like a dog walking app or something, I think my job would be very different than it is right now. And so I think for me, often, partly because of the team composition and the company's stages, it feels like sometimes it's been CTO, sometimes it's sort of been COO or like co-CEO, like just doing operational things internally, sometimes, and literally for most of the last year, sort of as CPO and was leading product. So I think for me, it's really needing in OctoML to be able to be the connective tissue. I view myself both, like, I think, as connective tissue between those functions and sort of catalyst to get some things to change, because I think you have these super smart engineers who are incredibly talented, but then you have product who has to understand an extremely technical product for an extremely technical crowd. And then you have like R&D where like new things are happening every 2.5 hours. And you then need to educate your go-to-market team and your sales force to be able to, and marketing to be able to talk about this and be able to understand it. And so I think it is like a really interesting version at OctoML where I feel like I sit between all of them and I spend time with everyone. Someone had told me, that as CTO, you could be like a chief evangelist or like kind of sales engineer. You can be like the version who's sort of the VP of engineering and like owns all of R&D. Or you can kind of be the version who's like a chief scientist, sort of tinkerer or hacker. And I don't think I'm really any of those exactly, because I do a little bit of all of those. But I think part of it's also because of the team. Like I have, for example, like my work partners, like our VP of engineering and our CPO are both like incredibly awesome to work with, and end up, kind of buffering some of the job. And so like when I was leading the product team, I think my job was a lot different than it has been for the last couple of months. But I think just being able to navigate that in that dynamism, because like back to when we first started, as you said, I was like, me and Tianchi were like the chief hackers, like we were the best programmers. Like that was our identity and like what we showed up as a company. And I think being able to like adapt that identity multiple times is really key, and like part of this, evolution, because, we didn't have a VP of engineering for a while, then we did. And so then I stopped managing a team. And then for a while I had some other people reporting to me, and then that changed. And so I'm actually back at like, I have 0 reports. And so it's definitely a different version though, where like I met someone actually this week who owns like all of product and all of like R&D effectively underneath him. And so I think it's really about what your company looks like, if that makes sense. But I think just being able to communicate and connect people, it feels like a really core part of what I'm doing.
And you're also in an interesting situation where the engineers that work for you also have a perspective on what the final product should be like. So they're almost also in a product type role in that respects, and that they kind of have perspectives. And whereas, if you're on a healthcare software company, it's like the engineers may not have that gut instinct for what's best for the customer there.
Yeah, no, I think that's part of what makes it like interesting, but also incredibly hard, because it's like everything that feels a little more like amorphous and poorly defined, where, and my version in tech is like a database. It's extremely hard to build a database, like technically, like, because you have to build one that is new in some ways. It's very hard to sell it because it's a super competitive market, but like how you sell it, how you build it, what it looks like is all really clear. And like, we don't have that in this market right now. Like no one really knows what they're building in the grand scheme of things, like, because even the needs are changing so rapidly that there isn't this like clarity of this perfect product picture, or like the healthcare system where like there's some, big customer who has clear requirements. And so I feel like everything has to be a little bit more intersectional and interdisciplinary. And I think that's also part of where, again, adapting to the company, like I need to like kind of be that synthesis function, because you kind of need like, again, your marketing people to even understand like the technical differences between like different quantization schemes and different, it's like, if you actually zoom out for a second, it's kind of crazy. Like if you pull an average PM, like the level of technical depth they need is extremely deep, and it's hard, or, it can be really hard if you're not a technical PM. With that said, like one of our PMs, Vanessa, has like a NeurIPS paper. So you can see like we're maybe not like the most traditional organization in that way. So
well, congrats. Actually, my paper, or our paper, I just got accepted in NeurIPS. So definitely I know the feeling of how excited they must be. Closing question, or closing 2 questions, would be, one is just, what is the AI industry going to look like in 1 year from now?
Man, that's like a tough question. I feel like I think we're going to see consolidation. I think we're going to see things become more verticalized, and I think we're going to see more complete solutions. I think if you look at like Runway released a new model this week, and the video looks awesome, but I think we're going to see people produce 2 to 3 minutes of video where the whole thing's like prompted, or, and there'll be a workflow for it. And maybe it won't be all the way there, but I feel like at the rate of innovation, the rate things are moving, we're going to see way more complete products. I also think we'll probably see the like trough of this disillusionment or whatever moment for some of the like first wave hype companies. But I think it's going to be really interesting, because what the big companies do is still really up in the air, because my feeling is if the market conditions don't change that much, there'll be a lot of M&A and consolidation in that world. I think the other thing that will be interesting is like, will building a model be a sustainable business for honestly anyone? Like, I think the leaders like OpenAI obviously are going to have a business, and it might change, but like there's 10 other companies behind them that have raised, $100-200+ million in capital. And it's like building a model really differentiated. I think that's going to be the biggest like thing that might change. Like I can imagine the answer becomes no, because I feel like we've already kind of seen on the image side where you can train a new image model relatively cheaply. Like the customizations we found even in our new product release, like if you get the options right, you can get mid-journey quality out without having to build a new model. And so there's like some of these questions of like, there's this kind of a concept, which is what I think about all the time, of Amdahl's law in computer systems, of like, if you have a system that is like perfectly parallelizable, then like you're good. But the reality is often you have some critical limited section that is not parallel, and like that is your limiting factor. And I think people don't really understand what that is in the system right now. And I think we believe that it might be the model, but it might turn out that like if you get a retrieval system to perform really well, that like you can actually get away with like a 7 billion parameter model that's been fine-tuned appropriately on much better data. And like we don't know that yet. And like those are the things that I think are gonna be the most interesting, because like one or two of those things coming true can just change the industry a lot, I believe.
No, I totally agree. And I used to specialize in deep learning systems performance. So how do you use distributed deep learning to train particularly like large language models or large vision models? And one of the reasons why I kind of have drifted a little bit from that specialization is because I also saw the same thing as, I'm working on training a model. Why can't OpenAI, with the best researchers and in addition exponentially more funding and dollars that can fund that compute costs and training costs, why can't they just beat me out in the marketplace if I just focus on training models? So definitely resonate with that last point.
Yeah, and how many winners exist, right? That's the other question of it. It's like, even if you can, are you going to be in the top 4, like, or what? I mean, maybe there's even room for 8, but like, there's probably not room for 8 is my feeling. And Google and Microsoft and Amazon are going to occupy 3 of those slots. So.
Yeah, I think it's really similar to 10 years ago asking, hey, like, is building a cloud platform differentiated? And one of my favorite quotes is I think it's from Mark Twain. History doesn't repeat itself, but it sure does rhyme. And I think we're seeing a lot of the rhyming elements here.
Well, so. I think that's an important lesson to take of all this stuff is like people forget when things feel concretely new that things are abstractly not very different, and history is worth studying. And, it's the same thing that's happened with Kubernetes or any of these like digital transformation waves where like everyone adopts something. It's like 1 or 2 Kubernetes people outside of the big companies accrued value, and no one else did. And same thing, honestly, with the cloud platforms. It's like the first movers who were also incumbent companies, a lot of capital and, scale economy and all the reasons that make it good for them won, and the Heroku's and the other like hosting platforms in the middle, like didn't really make it. And so I think that's also like maybe another final perspective is like, I think you kind of have to figure out like which side of the like parting sea you want to be on, because it's likely that middle will get hollowed out. Like it will accrue up to like more complete solutions and down to the infrastructure. And I think people keep saying they're building picks and shovels, but like Amazon is building picks and shovels. And I think a lot of people are actually building like snake oil, and they just don't know it, like, because they think they're building picks and shovels. And that's something I think about, like, honestly, every day.
Totally. Well, listen, we got to end with a fun question. And you're a fellow UW guy, so, got to ask, best shawarma spot on the Ave?
I got to go Aladdin's, like the grubby Aladdin's, like on 41st, 2nd, whatever, between the blocks there, because I used to go to Big Time a lot, which is a bar next door. I probably have had thousands of dollars of free beer there from my advisor. And that place was also the site of my like visit days lunch. So I have a lot of fond memories with different pairings of people in that place, even though it is a kind of a very grubby shawarma spot. And it's open to like 3, I think, was the other thing, which it's like one of the few spots that's open extremely late if you're up late and hungry.
Oh yeah. I saw Aladdin's in the notes. I'm like, this guy knows what he's doing.
Yeah, exactly. I mean, if you hang around the Ave enough, like, I mean, I spent a lot of late nights, like, one of my last all-nighters probably in grad school is I had to take a machine learning class, and I stayed up all night trying to finish the final thing or whatever. And then I was like, I don't want to do all-nighters anymore.
I think I trained my very first neural net in college in Aladdin's for part of it. So
I love it.
Only a weird set of memories from there, but to be cherished.
No, there's all those good places in your life that you end up spending a bunch of time. I think in my thesis, I thanked all of the coffee shops because I probably spent like half my PhD in aggregate hours at them. So.
Yeah, that is funny, Pierce. I do not remember where I trained my first neural net. But Jared, thank you so much for joining us today. It was a pleasure having you.
Yeah, thank you so much. I appreciate it. It was fun.
All right, everyone. That's our interview with Jared. Collective Nation, as we wrap up another episode of the podcast, I want to express my gratitude to our guests and to my co-host, and to you, our curious and passionate listeners. Today's discussion has once again illuminated the terrain of artificial intelligence and offering us a rare glimpse into the mind shaping the field. As always, we're building this podcast along with the GenAI Collective community, so please get in touch with us. Details for doing so will be in the show notes or podcast description. If you enjoyed this episode and would like to support the GenAI Collective or the Collective Intelligence Community podcast, please leave a review or a comment on your favorite podcast platform. Thank you for being part of this journey, and until next time, keep exploring, keep questioning.